maybe it was Sydney, I think so. Hi, Sydney. Asked a question about the foci. And then I wasn't sure exactly what she needed, so I'm gonna do 2 examples, Sydney, so hopefully I catch either thing that you needed. Let's say that, here's example 2, they want to know what are the foci of an ellipse with these radii. And the radii, they mean a length of A or a length of B. And what they did is they gave a picture. All right, and they wanted to know where the foci are. Here we go, here was the picture. There was a 10, negative 10, 8, and negative 8. And here was a picture of the ellipse right there. Okay, notice that the major axis goes from negative 10 to 10 because it's bigger than going from negative 8 to 8. So the major axis, you can hear that A in it. That would mean that my A right here is equal to 5. There we go. My B is half of the minor axis, and that would be 4. The foci, see how there's a C in foci and in focus, is C away from the center. All right, oh, I don't have a C. Figures, doesn't it? That's okay. I have an equation to get the C. Let's go ahead and get C. C squared equals A squared minus B squared. All right, let's put in our A. 5. Let's put in our B. 4. So we have C squared equals 25 minus 16, which equals 9. So C must be 3, because C squared equals 9. Okay, that means that the foci are 3 away from the center. Here's the center here. But which way do I go? 3 left and right, or 3 up and down? Well, what I know is that the foci are always on the major axis. So they are left and right of the center. So how do I do that? Here's how I write the foci. They're 3 away from the center. So I write the center and I leave myself spaces. My center is 0, 0. And the foci are 3 away, and we said they're going left or right, so that would be plus or minus 3, right? If they were going up and down, I would put that on the y. So I get 3, 0, and negative 3, 0 are where the foci are located. Now, in case that isn't what you needed, I'm going to erase this because there was another question on finding the foci. And I just wanted to make sure you had everything you needed, and I hope this is helping you. Please remember while I'm writing this, your job is to get a 60% on the exercises and on the quizzes, and I will input 100% into Power School, right? So I know so many of you strive for perfection. It's okay. We're just trying to get our basic skills in this situation. So foci from an equation. All right, x minus 2 squared over 3 plus y minus 5 squared over 7 equals 1. I can see this is definitely the equation of an ellipse. I can see that the center is at 2, 5 because we know where the h and the k is. Now, how do I know if this has a horizontal or a vertical major axis? I look for the biggest denominator. It's underneath the y, so this must be vertical. Why am I going to need this? I'll let you know in a second. They asked for the foci. Okay, well, that is C away from the center. Well, this right here is B squared. This right here is A squared. Wouldn't you know, I need C. right? And so that's okay. We have this formula right here. Let's get our C. C squared equals A squared minus B squared. Now this is kind of cool. I have A squared, it's 7. It's right there. There we go. I have B squared. B squared is 3. There we go. It's right there. Oh, this works out nice again. C squared equals 4. That means C equals 2. All right. That means the foci are C away, 2 away from the center point. All right. Let's write the center point. We said the center is 2, 5. Notice I leave myself lots of space. All right, well, the foci either go up and down 2 or left and right 2. How do I know? Right here, we said this was a vertical ellipse. We know the foci lie on that axis. So we're gonna go up 2, down 2. So plus or minus 2 on the y. There we go, that would be 2. 5 plus 2 is 7. And 2, 5 minus 2 is 3. And these are the foci. So I sure hope that helps. I so wish I could be with you for conic sections class because they're so cool and there's so much I do with it. And I do think it's more understandable. So don't stress yourself out. Just keep asking me for help and we're all gonna do the very best we can. Have a good day.